Okay, weight and balance. How does it work? This is a weight and I'm unbalanced. All right, so this weight weighs 2.5 labs, however much that is. It's that heavy. This right here, this dot here, represents the center of gravity for this Tupperware, meaning that that is, if you averaged all of the weight for the entire thing, that's the average of where the entire Tupperware is in a single point. What does that mean scientifically speaking, or just practically speaking? It means that if I put this on the edge, anytime the dot is not off the table, it will stay on the table. As soon as that center of gravity becomes unsupported, like so, it's going to tip off. And also, it should make sense to you that the further that center of gravity is in, the further supported it is, the more stable it is. That's not very stable. That probably makes sense to you. So, center of gravity, it's basically, if you could suspend the thing on a single point, where would it balance? That's center of gravity. Weight. I think you have a pretty decent idea about what weight is. Now, levers. What are they? How do they work? Archimedes took a bath 1,000 years ago, and now we're here. In fact, he took a bath for longer than that. He was a prune when he got out. So, long end, short end. Fulcrum. You go like this, you get a small force on the long end, a big force on the short end, large distance of travel, small distance of travel. This is how the gearbox in your car works. I could, if I had more than one hand to use, take this nail out of here easily, like that, when it would be very difficult by just pulling up. Just as a demonstration, this is 45 pounds here. Here's my lever, one finger. Okay, levers. All right, so now let's talk about airplanes. Ignore Franklin in the background. This is my airplane, maybe. We've got this weight here, which is going to simulate the weight of the engine, and we have this here, which is tied to this, which has got a scale on it so that we can measure the force that the airplane is experiencing through the wing. And we have this tied down here so that it can't come up. This is simulating the tail holding the airplane level. The tail is just an upside down wing making lift in the opposite direction as the main wing. And this is not a time for aerodynamics, so we're not going to get real into that. Now, what we're going to do is, you can see we've got this string here and an S hook down there. We're going to put the 2.5 pound weight on the S hook and see what the scale reads.
So, 2.5 pounds.
Yes, I am wearing Crocs. It just means I'm smarter than you. Okay, so that's on here. Actually, we don't want to put that on there yet. I take back my comment about being smarter than you. I need to turn on the scale. All right. Go. Okay, zeroed out. Putting on the weight now. And we have 2 pounds, 9 ounces. Pert near 2.5 pounds, I'd say. Now, we're going to take this guy off, set him down here, and we are going to move this forward. Okay, now it's up forward. We're going to re-zero the scale, and we're going to put this guy on now, 3 pounds, 4 ounces. How does that work? Did the weight magically get heavier? No, what's happening is there's a lever arm here, okay? And it's making the plane want to tip down. The plane is not allowed to tip down because of this tail back here. And so for every pound that we add ahead of the wing, we have to add additional downforce on the tail to balance it out. So this is why, if you look at a weight and balance chart, it's going to look something like this, right? Where this is your weight, more weight up here, less weight down here. This is your CG range. We call this the weight and balance or CG envelope here. That's why you can carry more weight at the rear of the CG envelope than you can at the front, because at the front, that weight is causing additional weight because of the tail pushing down on the airplane. That's also why that tail pushing down on the airplane is making lift. That lift is making drag. That's why the most rearward center of gravity is going to allow the airplane to fly a little bit faster and a little bit more efficiently than the foremost center of gravity. So you say, okay, well that's cool, so why don't we fly out over here as far rearward center of gravity as possible? Here's the problem with that, champ. The weight, if we move it back here, as we move it back, so this thing is quite, well, except for that, my string moved. Hold on. This thing is quite stable in this configuration. As we move this weight back, it's going to move the center of gravity back. And remember, right now, the center of gravity is up here, right? Airplane wants to tip down, but it's being held off by this, or basically counterbalanced by this. And here's our center of lift here. As long as the center of gravity, which if we ignore the rest of the airplane, is going to be the average between these 2 points, which is so like right here, it's the center of gravity. As long as the center of gravity is in front of the wing, the thing is stable. It's going to stay there. As soon as, if I disturb it, it's going to come back. It's going to come back to a balanced state, right? And my string went again. However, if I move this to the rear, you can see if I disturb it now, look at how much less stable this is. This is not stable at all because the CG is now behind the wing, and you not only have this guy pushing down, but you have the CG pushing down as well, which means there's no mechanism for the airplane to go like this. And you say, well, okay, well, couldn't I just push the nose down? And you could, but there's other problems that we get into there with stability, and that's a topic for an aerodynamics discussion. But rearward center of gravity equals less stable, but more efficient. Forward center of gravity equals more stable, but less efficient. It's highly imperative that you keep the center of gravity between the envelope for your airplane. Weight, I think it's pretty explanatory to tell you why too much weight in the airplane is a problem. Too little weight, you're just going to perform really well. It's not a lot of problem there. All right, so we're going to come back with a technical analysis in a minute. I've sort of shown you how the system functions, the science of it, and then we're going to do some math, which is everybody's favorite, here in a second.